Good morning, class. Take two. Today we're going to be doing a lesson on quadratics, but we have talked about quadratic functions in the past, and now we want to switch to talking about quadratic equations, specifically how to solve those. So if we get started here, we're going to switch to our desktop. We are going to be talking about the quadratic formula. There are many ways to solve the quadratic equation. However, the quadratic formula is just the end-all be-all. You can apply it to any quadratic equation and get a solution. There are certain requirements you have to be aware of, which we'll discuss. And we're specifically going to focus on real solutions, and I'll introduce the discriminant and its function a little later in the video. So if we get started here, our target today is to learn the quadratic formula. What is it? We want to learn how to write a quadratic equation. Again, it must be in a certain form before I can apply the quadratic formula. We want to be able to identify the coefficients in the quadratic equations and substitute and solve into the quadratic formula. So anyways, let's get started. This is the formula, all right? X equals opposite b plus or minus the square root of b squared minus 4ac, and all of that is over 2a. Some of you look at that and say, that looks complicated. Well, it's not really, and there is a way to memorize this, which you do need to memorize. The quadratic formula can be memorized. There are songs on YouTube that allow you to learn the quadratic formula, but in the form of a song. So it makes it not so hard to memorize. And one such song I'll do for you now. Opposite b, plus or minus square root, b squared minus 4ac, b squared minus 4ac, all over 2a, all over 2a. See, there's a cute little song that allow you to memorize this formula quite easily. So if you guys want to check those out on YouTube or rewind the video and play this song again, that's fine. But let's see how we use the formula. What does it do? Well, the quadratic formula is used to solve a quadratic equation, and that equation takes the form of ax squared plus bx plus c equal to 0. The important thing about this formula is this right here. Everything has to be equal to 0. I cannot have anything on the right-hand side of that equation other than 0. If I do, I cannot apply the quadratic formula. So anything that sits to the right of the equal sign must be moved to the left-hand side of the equation before you apply the quadratic formula, okay? And again, our warning, okay? So please, again, take special note. A quadratic expression must be isolated on one side of the equation. Everything has to be equal to 0. Only one side can contain 0 for you to apply the quadratic formula, okay? So that is a warning. If you try and pull the coefficients of this quadratic equation before you get everything equal to 0, you will get a completely wrong answer. It is so important that you follow this rule. All right, let's look at our first example. We want to be able to identify the coefficients, the a, b, and c, in our quadratic equation. Now, if we look at this example, we have x squared plus 3x minus 7 equal to 0. So in this case, we actually have everything equal to 0. So my requirement is met, and I can now apply the quadratic formula. But again, we're not going to write the formula per se. We want to be able to identify the a, b, and c. We know the form of the equation that it solves is ax squared plus bx plus c is equal to 0. So if I compare this to what I've been given, I'm going to look at the first term, and the coefficient in front of the x squared term in this case is a 1. It's not written, but it's understood to be 1. So in this case, our a is equal to 1. If we go to our next coefficient, the b multiplies x. In this case, we have a positive 3. So we want to take the sign with that number. In this case, it's positive. So I can say my b is equal to 3. And then over here, our c is just the constant term. But again, I want to take the sign with the number. In this case, it's a minus 7. So in this case, our c is equal to a negative 7. And these are the coefficients that you would use to substitute into and solve the quadratic formula. Here we have another example, and again we want to find the a, b, and c that you would use to solve the quadratic equation. And by solve, for us, we're talking about solving with the quadratic formula. So we need our a, b, and c. If you notice, we have a problem. We don't have everything equal to 0. We have 2x squared equals 5x minus 9. So in this case, I want to be able to rewrite this equation. So we want to first subtract our 5x from both sides. What this does is it gives us on the left-hand side 2x squared minus 5x equal to, in this case, 5x minus 5x is 0, and what's left on the right-hand side is a negative 9, okay? Now, we still don't have everything equal to 0. I have to get rid of the negative 9 on the right-hand side. To do that, I do the opposite. I'm going to add 9 to both sides of the equation, okay? So we get 2x squared minus 5x. Notice, guys, I can't add 9 plus 2. Why? Because there's not an x squared on the 9, and they're not like terms. I also can't say 9 minus 5. Sorry, I accidentally hit the button to erase. I can't say 9 minus 5 because this 9 doesn't have an x. So again, these are not like terms. So the 2x squared minus 5x, you copy down. You don't do anything with those. And then this plus 9 comes down. And here we have 9 minus 9 is equal to 0. So now we've met our requirement to be able to pull our coefficients a, b, and c. So all I have to do is write underneath this, and I'll do that in a different color. We can write ax squared plus bx plus c is equal to 0. And now I want to pull my coefficients. So in this case, the number multiplying x squared is a 2. So I get a is equal to 2. Here I have this b, and again, I want to pull the sign with that. So my b is equal to a negative 5. And then here, I have c is just equal to a positive 9. And these are the coefficients that I would substitute into and solve the quadratic formula. And that would give me my solutions to the quadratic equation. All right, so let's move on. This is one for you to try. I want you to identify the coefficients, and by coefficients, we're saying the a, the b, and the c of ax squared plus bx plus c is equal to 0. So I want you to do what we just did on this equation. So if you can, just pause the video, find your answer, pull the coefficients a, b, and c. Remember, everything has to be equal to 0 before you pull the coefficients. and then hit play and check your answer. So pause the video now. All right, guys, back to the problem. You guys should have, on this problem, seen that you had a 24 on the right-hand side and that this 24 must get to the left-hand side for you to be able to apply the quadratic formula. So your first step should have been to subtract 24 from both sides. You also notice that this goes to 0. This 24 is not a like term with 2x squared. It's not a like term with negative 2x, so we can't combine those. So the 2x squared just comes down. A minus 2x just comes down, and this minus 24 just comes down. And now you have everything equal to 0. Again, I can write my ax squared plus bx plus c equal to 0. And now my coefficients are easily identified. I have a is equal to 2. I'm going to come over to the side here and write that out. My b, again, we want the sign with it. So that would be a b value of negative 2. Okay? And notice how I'm writing my negative away from the equal sign. We don't want the negative to get lost in our equal sign. And here we have a c. Well, this is a minus 24, so we want to pull the sign with that. So c has a value of negative 24. All right? And then we're done. So these are our coefficients that we would use to substitute into and solve our quadratic formula. All right? So here's a you try it. This is the one we just did. So let's move on. All right, example 3. We want to solve this quadratic equation. So we're going to take what we just learned on identifying the coefficients, but now we want to substitute into the quadratic formula. Okay? So first stop is to make sure we have everything equal to 0. Do we have that? Yes, everything right here is equal to 0. So we're good to go on that. So now we can identify our coefficients. So if this is ax squared plus bx plus c equal to 0, then my coefficients are just a equal to, in this case, remember it's not written, but it's understood to be a 1. So we have an a value of 1. We have a b value that multiplies the x. That would be a positive 5. And we have a c value. The c value is a positive 6. All right? And we want to write down our quadratic formula. Okay? So this is just x equal to, and again, if you want to sing the song, opposite b, plus or minus square root, plus or minus square root, b squared minus 4ac, b squared minus 4ac, all over 2a. All over 2a. Yep, I'm going to get signed. A music recording contract is on the way, I'm sure. So anyways, now we can substitute into our formula and simplify. So we're going to substitute in. Our opposite b is opposite, and I'm going to use parentheses when I'm substituting. So b is a 5 plus or minus the square root of b squared, again b is 5, minus 4 times a is 1, c is equal to a 6, and all of that is over 2 times a has a value of 1. So we want to simplify each part. So in this case, I get a negative 5 plus or minus the square root. 5 squared is 5 times 5. And you guys know 5 times 5. Don't get on that calculator. What's 5 times 5? That is 25 minus 6 times 4, 24. And all of that is over 2 times 1, which is just 2. And then we're going to come up here and continue on. So we get x is equal to opposite b plus or minus the square root. Notice how 25 minus 24 is just a 1, and all that's over 2. So I get x equal to negative 5 plus or minus. The square root of 1 is just 1. Why? Because 1 times 1 is equal to 1. And all that's over 2. So now we get to talk about, what does that plus minus mean? It means we're looking at two different numbers. We have a negative 5 plus 1. We have a negative 5 minus 1. So we want to look at our two values of x. I'm going to write this in a different color. We'll say our first x value is negative 5. We'll say plus 1 divided by 2. So we get x sub 1 equal to negative 4 divided by 2. So our first x value is a negative 2. All right. So that's our first solution. And now our second solution, we're going to look at negative 5 minus 1 over 2. So again, that's our plus minus. We have negative 5 plus 1, negative 5 minus 1. So negative 5 minus 1, that's just equal to a negative 6 divided by 2. And so our second x value is a negative 3, because negative 6 divided by 2 is a negative 3. That means our solutions, which I can write in set notation using fancy braces, are just a negative 2 and a negative 3. Okay? And I apologize because normally I write the smaller value first. Okay? I like to do that when I'm in set notation. But that is our solution. Okay? So again, this isn't hard. You identify your A, B, and C only after you have everything equal to 0. Then you substitute into your quadratic formula. I suggest writing the formula down first and then doing your substitution. And when you're substituting, make sure you use parentheses. Then it's just a matter of simplifying and eventually solving for your two solutions. Okay? All right. This is another example. We're going to solve this quadratic equation. So in this case, we have some interesting things going on. If you notice, we have a 2, a 2, and a 24. I could simplify this before I start, which may help us as far as our numbers, because we'd be working with smaller values. So if I divide everything here by 2, then I get the equation x squared minus x is equal to 12. Okay? And then I want to get everything equal to 0. I can't apply the formula until I have everything equal to 0. So we have to subtract 12 from both sides. And you end up with x squared minus x minus 12. All that goes to 0. So we have everything equal to 0. And now we can pull our a, b, and c. So we're going to write ax squared plus bx plus c is equal to 0. So now our a value is understood to be a 1. Our b value is understood to be a negative 1. And our c value is understood, well, it's just the constant with the sign, which is a negative 12. So we have several negatives in this one, but that's okay. Not a problem. We're going to substitute in to the quadratic formula, which we have x equal to opposite b, plus or minus square root, b squared minus 4ac, b squared minus 4ac, all over 2a, all over 2a. And we want to substitute. So we have an opposite b. And now you see why I like to use parentheses. This b is negative. We don't want to confuse the negative on the value of b with the negative in our formula. Okay? So this is opposite of a negative 1 plus or minus the square root of b squared. Again, I'm going to put negative. B squared minus 4 times a is 1. C is a negative 12. And all of this is over 2 times 1. And we're going to come up here and continue on. So if I simplify this, opposite of a negative 1 is a positive 1, plus or minus the square root. B squared is equal to a 1. Negative 1 times negative 1 is a positive 1. A negative 4 times a negative 12. Negative 4 times negative 12. Well, a negative times negative is a positive, and 4 times 12 is 48. And all of that is over 2 times 1 is 2. So if I simplify this a little bit further, I get 1 plus or minus the square root of 49 over 2. I hope you guys realize 49 is a perfect square. We can take the square root of that. So the square root of 49 is 7. So we end up with x equal to 1 plus or minus 7 divided by 2. All right. Remember, the plus or minus, we're looking at two different numbers. Okay. So our first solution, x of 1, would be 1 plus 7 divided by 2. So x of 1 is equal to 8 divided by 2. 1 plus 7 is 8. And then 8 divided by 2 is just equal to 4. Okay? Our second solution, we're going to take the minus in our plus minus. So we're going to say 1 minus 7 divided by 2. So x of 2 is 1 minus 7. Well, that's the same as saying 7 minus 1 and given the sign negative. The bigger number is 7 there. So we're going to make it negative. So 7 minus 1 is 6 and give it the sign of the larger number negative, which is our 7 there. And we get negative 6 divided by 2 is a negative 3. All right. So our solutions are negative 3, 4. And that would be your solution to this quadratic equation. Okay? All right. All right, this is one that you guys can try. Please pause the video and see if you can identify your A, B, and C, and then substitute into your quadratic formula. Remember to write it down first, and then simplify and get your two solutions. So you guys pause the video now. All right, so we want to solve this quadratic equation. We have space here. I didn't do a separate slide for this, but that's okay. We'll make do. We will. We already have everything equal to 0. So if I write down my ax squared plus bx plus c is equal to 0, then we know a is equal to 1, because that's understood to be 1 times x squared. Our b is equal to a negative 7, and our c is equal to a positive 12. So now we want to write down our formula. Okay, so our formula is x equal to opposite b plus or minus the square root of b squared minus 4ac, b squared minus 4ac all over 2a. And now we want to substitute. Okay, so again, I'm going to use parentheses while I substitute. So our opposite b is opposite of a negative 7. Plus or minus the square root of b squared is negative 7 squared. Minus 4 times a is 1. C is equal to a 12. And all of this is over 2 times 1. And again, now we want to simplify. So this is opposite negative 7, which is a positive 7, plus or minus the square root. Negative 7 squared is a 49. guys, if you do -7 squared on your calculator without using parentheses, you are going to get the wrong answer. Okay, if you're using the TI calculator, you have to put that -7 inside parentheses because the negative gets squared also. And then we have -4 times 1 times 12 would be -48. And then all of this is divided by 2. So we have 7 plus or minus the square root of 1 over 2, which is just 7 plus or minus 1 divided by 2. So we have two values there. If we look at our plus and minus, our first solution is going to be 7 plus 1 divided by 2, which is just 8 divided by 2, which is a 4. And then we have x sub 2. Well, that's equal to 7 minus 1 divided by 2. Again, we're pulling the minus on our plus minus. 7 minus 1 is 6 over 2, which is just 3. So our solutions here for this quadratic equation are simply 3 and 4. Okay? All right. And there you have it. All right. They get radical. In that sense, they get kind of ugly. Does everything simplify when you do the square root? Not always, guys. Some solutions are irrational, and you'll end up with a square root in your solution, and that's okay. It's perfectly fine. That's just how it works out. You let the problem be what it is, and you simplify it to the degree possible, and once you're done, you're done. Okay? So let's look at this example. We have a situation again where we don't have everything equal to 0, so I must move my 2x plus 5 to the other side of the equation. Now in this case, I'm going to remind you about moving terms, okay? Because if I move 2x to the other side and I move 5 to the other side, what happens to the signs? We said if I move a term, it changes sign. So instead of saying minus 2x, I could just simply say x squared. This becomes a negative 2x because once it crosses the equal sign, I change the sign. This plus 5 becomes a negative 5, so minus 5 equal to 0. And again, to me, that's the quicker way to do it. I've shown you that in the past. It's transforming the term. You move the 2x to the left side. Well, that crosses the equal sign, and it changes the sign. The 5 crosses the equal sign. It changes signs. Okay? So now we have x squared minus 2x minus 5. Now we want to write down ax squared plus bx plus c is equal to 0. And our coefficients are a equal to 1. B, again, don't forget the negative. B is equal to a negative 2. And c is equal to a negative 5. Okay? So now we want to substitute into our formula. And remember I told you, always write down the formula first before you start doing substitutions. And my dog is sitting down here beside me again. Now he's grunting at me. Calm down, Bruce. So we get x is equal to the opposite of b. Again, we want to use parentheses because that b is negative. Plus or minus the square root of b squared, that's negative 2 squared, minus 4 times a times c is a negative 5. Okay? And all of that is over 2 times 1. Okay? So if we simplify this, we get opposite of a negative 2 is just a positive 2. Plus or minus the square root. Negative 2 squared is a positive 4. Negative 4 times negative 5 is just a positive 20. And all of that is over 2. So that's just 2 plus or minus the square root of 24 over 2. All right. Now, guys, how do you simplify a radical? Well, we have to be able to do that. So in this case, I'm going to go up here. And we're going to say x, oh, can't write if I'm erasing, x is equal to 2 plus or minus the square root. Well, this, guys, is equal to 6 times 4. You want to identify the perfect squares in 24 to be able to simplify the radical. And 4 is a perfect square because it's 2 times 2. Okay? And all of this, again, is over 2. Don't lose that. Now, 6 is 2 times 3. That's 2 prime numbers. I can't take the square root of 6. But I can take the square root of 4 and bring it outside. So we have x is equal to 2 plus or minus. The square root of 4 is equal to 2 times the square root of 6. That 6 stays under the radical. And then I divide by 2. Now, notice right here, I can divide 2 into the first term and 2 into the second term. So this is really 2 over 2 plus or minus 2 square root of 6 over 2. Our 2's cancel and give you 1. 2's cancel here and give me 1. So my x is just 1 plus or minus the square root of 6. And again, that's my 2 solutions. So my solutions are simply 1 minus the square root of 6 and 1 plus the square root of 6. Okay? And there you have it. So again, not all of these simplify to nice, pretty numbers. Some of them have irrational solutions, which means you're going to have a radical in them, but it is perfectly all right. You let the problem be what it is, simplify it like we did down to the simplest form, and then you're finished. Okay? All right, so here's one you can try. So I want you to try this one. So make sure you get everything equal to 0. Okay, pull your coefficients, substitute, and simplify to find your solutions of x for this quadratic equation. So pause the video now and you give it a shot. All right, we're back. I hope you guys were successful in solving this quadratic equation. Again, in this case, I don't want to move both terms over, so you may have done this a little bit different than I am. So I'm going to write in red first. I want to move this x term to the right-hand side. Like, why? It's okay. I can do that. What that does is it gives me a 0 on the left-hand side. And I get 3x squared minus 9 minus x, because that positive x becomes a negative x. Now, all I can do is just flip the left-hand side and right-hand side. It doesn't matter. So I get 3x squared minus 9 minus x is equal to 0. Now, guys, another thing to watch out for, these terms have to be in order, okay? I need x squared, x, and then the constant before I pull my coefficients. So these two are going to trade places, the negative 9 and the minus x. So we're going to write 3x squared minus x minus 9 is equal to 0. And now I can look at ax squared plus bx plus c is equal to 0. And I can pull my coefficients. A is equal to, ooh, see, I'm in a rut. I'm in a rut. Do you see that? I'm writing 1 and it's not a 1. It's actually a 3 this time. Okay. Then my b is equal to a negative 1. And my c is equal to a negative 9. So now we want to substitute into the quadratic formula, and I want to write that out first. Hopefully you guys are getting this down. Like, you can just write it out. Okay? And then we want to substitute into the formula. In this case, we have opposite b, so this is opposite of a negative 1, plus or minus the square root of b squared, that's a negative 1 squared, minus 4 times a is 3 and c is negative 9. And all of this is over 2 times 3. Okay? So you also don't always get a 1 on the bottom with the 2. So now we want to simplify this. We get opposite of negative 1 is a positive 1, plus or minus the square root of 1. Negative 1 squared is a positive 1. We have a negative 4 times 3 times a negative 9. Well, we know negative times negative is a positive. Okay, so we're going to do positive. And we want to say 3 times 4 is 12. And 9 times 12, you should get 108, I do believe. And then all of this is over 2 times 3 is 6. Okay. So guys, can we simplify this? Can we simplify this? We have 1 plus or minus the square root of 109 divided by 6. I don't think 109 can be factored. If I'm not mistaken, it's prime. And you guys can correct me if that's the case. You can do so in the comments on this video. But for now, we're going to say we're done. Okay. And yeah, I think we're done with that one. Yes. So if I look at this, we can now say our solutions are equal to 1 minus the square root of 109 divided by 6, and also 1 plus the square root of 109 divided by 6. Okay? And that is your solutions to this quadratic equation. Again, they don't always work out as nice as some of the earlier ones, but it's okay. It's the same process, and you guys can do this. All right. In other cases, okay, the ones we were solving, guys, had 2 solutions. So we were looking at 2 distinct real roots, which is the case right over here. Okay, this is what we were looking at. Okay, this is where your d, that b squared minus 4ac, that's called your discriminant. It's what sits under the radical in the quadratic formula, or under the square root, if you want to call it that. So if that d value is greater than 0, then I get 2 real roots. Well, there are other cases when d could be equal to 0. In that case, you get 1 repeated root. It's where your parabola actually touches the x-axis. And then when d is less than 0, I have no real solutions. I get imaginary roots because we don't cross the x-axis at all. Okay? So again, when we talk about solving the quadratic equation, what you're really doing is solving where your quadratic function crosses the x-axis. Okay, so the roots of a quadratic function, or your zeros of a quadratic function, are the roots of your quadratic equation. Okay? All right, and I think that's it for us. So we are done. I thought I had a summary slide on here, but I don't. So again, our quadratic formula is not too difficult. You have to commit it to memory. Be sure, in summary, that you always make sure your quadratic equation has everything equal to 0. You have to have 0 on one side of the equation before you pull your a, b, and c. And then take your a, b, and c, substitute into your quadratic formula, and simplify to solve for your 2 roots. And that is all for today. I hope you guys enjoyed it, and I hope you enjoy working with the quadratic formula. Thank you.